Let us try multiplying two surds. In the first example, you see two surds, root 5 and root 2. They are pure surds actually. Um, what we normally do is, if we look at a surd, we try to simplify it further. Can 5 be simplified further? No, because 5 is already a prime number, it cannot be factorized further. And the same happens with 2. All you can do is to club them together under the same root, because this is also a square root and this is a square root too. You can multiply the surds. In spite them being unlike surds, they can be written together under the same surd and multiplied. The final answer is root 10. The second question contains two mixed surds and they are unlike 2. That's okay. All you can do is multiply the whole number part. So 2 times 3 is 6, and you write down the radical part of the surds under the same root and multiply. We are not going to be multiplying them actually. What we are going to do first is simplifying them first. So 12 can be written as 4 times 3. This is how I wrote factorization of 12, because 4 is a perfect square and I know that square root of 4 is 2, which simplifies it further. However, same does not happen with 15, because the factors of 15 are simply 3 times 5. There's no square root involved, and that's again okay. In the next step, I write 6 as it is. The square root of 4 is, I know, 2, which is a whole number, and hence it is written outside the root. 3 times 3 is paired, and 3 times 3 is 9, and I know the square root of 9 is 3, which is a whole number, so it is written outside. This poor guy, 5, is unpaired and it remains inside the root. Let us simply multiply the whole number part. 6 times 2 is 12, 12 times 3 is 36, 36 root 5 is how you get your final answer. Question number 3 is about two surds that are, one of them is a mixed surd and the second is a pure surd, and the method is just the same. Let's see how you can do. 10 is a whole number part for the first surd. For the second surd, there is no whole number part. So 10 is written as it is, whereas the two radical parts are multiplied together under the same root. In the next step, 27 can be written as 9 times 3. So 9 3s are 27 and 9 is a perfect square. Again, we do the same with 32. 32 can be written as 16 times 2. Now, why 16 times 2? Because 16 is a perfect square. Okay, 10 is written as it is. Square root of 9 is 3, which is a whole number and hence written outside. Remember that all the whole numbers are to be written outside the root, whereas all the non-whole number parts are irrationals are to be written inside. Okay, now again, we know that the square root of 16 is 4, written outside. All the leftovers are written inside. Now leftovers are 3 times 2, which is 6. All you got to do is just multiply these numbers outside. 4 3s are 12. 12 times 10, 120 root 6. For the next question, I have root of 200 times root of 98. Now again, you can either completely prime factorize these numbers, or you can write them as a product of a square number and a prime number. So 200 can be written as 100 times 2. 98 can be written as 49 times 2. because 100 is a perfect square, 49 is a perfect square. So the square root of 100 is basically 10. 2 remains inside the root. The square root of 49 is 7. 2 remains inside the root. All we got to do now is to simply multiply them. The whole number parts multiplied together. 10 times 7 gives you 70. So root 2 times root 2, meaning root of 2 times 2. So if you see 2 times 2 is 4, and the square root of 4 is again 2, which is a whole number. So 70 times 2 gives us 140 as the answer. This one was pretty easy. Let's take up last question, which is 3 times 22 times 4 root of 66. These both are mixed surds which have whole number parts as well as the radical parts. So whole number parts multiply together 3 times 4 and the radical parts multiply together 22 times 66. If you have been observing carefully, in this question, in the question number 4, second step, I have not clubbed them together under the same root. However, what I have done is I have factorized them first. Whereas in question number 5, I have written them together under the same root, and then after that I'll be factorizing. It is up to you. Whatever you want to do first, your final answer is going to be absolutely same. So 3 times 4 gives you 12. 22 can be factorized as 2 times 11. 66 can be factorized as 11 times 2 times 3. What can be paired from here? 11. So what I have is 12 times. So from this pair, I know that 11 times 11 square root is going to be just 11. And then I have this 2 paired. So the square root of 4 is basically 2. This guy is unpaired. It remains inside the root. All you got to do is simply multiply them. 12 times 11 gives you 132 times 2 root 3. And then you just got to multiply this. 2 2s are 4, 6, 2 root 3. That's about it. Thank you.